just Ladyada.
Hi, everybody, and welcome to the desk of Ladyada, the pre-eclipse edition. So everyone going in North America who's going to see this eclipse tomorrow. Hopefully we will see it here in New York City. But in preparation, I have designed some hardware. So let's go to the overhead. I'll show off some of the testers that I just did. So I got a bunch of final PCBs in, like the, hold on, there you go. The BNO BFF. This is a BNO055 9-DOF sensor, which has a built-in microcontroller. Actually, ironically, a SAMD21, which then converts it from like XYZ into like quaternion, angle or Euler angles. And there's also a BMP280, which will give you precision temperature and barometric pressure sensing. I set it against humidity sensing because I figured like we have a lot of low-cost humidity sensors and most people want to know altitude. And that's what the BMP280 would give you. And some jumpers. This is the tester that we designed. And let's see if I can power it. It uses a RP2040. And the only thing that's a little tricky is you have to have it upside down because I want to test all of the jumpers. So you have to have the board upside down. I'm going to move this a little bit so it's a little easier for me to align. And then live demo, but I think I can do this. It's this USB upside down. There you go. See it, it beeps and the LED blinks, letting you know that it passed test. It does take a few seconds because whenever you want to change the address or reset the BNO055, it takes like 400 plus milliseconds sometimes for it to like wake up and start responding to I2C. I don't know why. Anyway, so that's the BNO055. I've also got the two infrared boards that I worked on. Hold on, this way and this way. So with these, they're actually, they seem similar, but they're actually, the testing was like totally different. So for this one, this is like a general purpose IR receiver. And so for this one, I have to test, I test a signal from the vertical and horizontal infrared. So there's two sensors here, horizontal and vertical. And I want to make sure that both are working. So I have to like listen on both. Another thing about infrared receivers as opposed to, this board, the other board, which is a infrared demodulator. The demodulator is like it doesn't have any like brains to it. It's like if it gets 38 kilohertz signal, the pin goes low. It's like very, very basic. Whereas the infrared receiver is actually looking for pulses that conform to a certain number of pulses and the width of the pulses. That's because it's looking for infrared remote codes, and the codes like are on off like dit da dit da dit da. This one doesn't care, and so the tester is actually different. What this tester does is it sends a short number of control burst codes and checks the horizontal and vertical. So let me just quickly show that off. And it's very fast. You can even see it's getting the signal here. And then the demodulator is a little bit different. I mean, you can't really tell the difference from the tester itself, but this is a continuous stream. Oh, yeah, it's kind of nice. You can see. So you see how it's like a continuous stream? It's sending out a continuous stream, which means that this board should not be passing. So if I test this, yeah, it actually like doesn't see the signal because there's so many pulses that this infrared receiver is like, yeah, that's not a valid receiver code. It must be like ambient noise or something. Whereas the demodulator, hold on. Yeah, the demodulator is happy to show exactly the signal that it's receiving. So you see these are both lit up at the same time. For different tests and different breakouts, because I think a lot of people are gonna be like, why do you have two breakouts? What's the difference between these two? This one is perfect for remote control reading, and this one is perfect for, it can do remote controls, but what it's better for is general purpose, like you're bouncing an IR signal or you're sending data over IR that isn't in remote control protocol style. So those are the three testers I worked on yesterday. Another board that I wrapped up is I've had one last mistake. You can see here this little wire for the USB host BFF. But the final mistake I made was so small that I'm comfortable with booking the PCB just with this like little wire fix. Basically, one of the things about CAD software is it's very easy to like I thought that one pin was labeled a certain way, but it was actually another way. And I ended up swapping the inverted and non-inverted 5-volt enable signal in case you wanted to disable the power to the micro B port. So I ordered these PCBs out today. So that's kind of fun. I think this can be good for some projects where people want to make like very small USB adapters or converters, especially if this was soldered right onto the back here, which you can kind of put it like piggyback. Let's see if I don't think I have the host here, but like the PCB is, yeah, I put it away. But the PCB is thin enough that, you can solder them just like this, and then, cut the leads off, and then you've got this like very short sandwich, but enough clearance that if there's any components on the back, they're good to go. And then of course, if you have the boards that have an antenna here, you don't want to have the this micro B port in the way. All right, how are you doing on time?
Doing good.
Okay, let's go to the computer and I'll show off some, oops, wait, I don't want to put that in there. There's nothing more deadly than putting the wrong component in a box, because then later you're like, where's that part? And I can't find it. And it's in a box. And all of our boxes look the same. They're all black. Okay. I designed a couple Trinkeys. So one is a request from AT Makers for a TRRS Trinkey. And this one has, as you'd expect, a TRRS jack. So that's something that's a tip ring sleeve. So it's used for like, old iPhones back when or phones when they were allowed you to just plug in a headphone jack. They'd have stereo, so ring and tip, and then the second ring would be for microphone. So it's 4 contacts. And that means you can also split the signal a bunch of different ways. And then 2 of the pins also have switches on them. So the tip and the first ring have a little switch, and the switch disconnects. So you can use it for detecting when something's plugged in or for a routing signal. And the request we had was to put every pin on an analog input and not connect it to like power or ground. Like there is a standard like sleeve, usually sleeve is ground. But sometimes there's different standards, and sometimes you want to put power on a pin and sometimes you don't. And so basically this has every pin connected to a GPIO. So you have like full freedom on what you want to connect it to. Only thing is you're not going to be able to source a lot of power. So you can like light up an LED or maybe drive a potentiometer, but I definitely wouldn't be able to control a motor. But maybe that's okay. There's some accessibility switches that are potentiometers, or they maybe have a little LED, or maybe they have 2-way switches. And then it goes into the SAMD21. Like I mentioned, we have like a billion SAMD21s because I ordered 2 years worth and they all shipped in 1 week. Little NeoPixel for signaling. You could do on CircuitPython on this. And then unlike the other Trinkeys, like this one where I have the USB into the PCB and I just use a 2mm thick PCB. Only thing is that like it is easy to pull out. I'm just go the overhead real fast to show it. I mean, it grips, but it's like, it will plug in and it sits, but like if it does yank out quite easily because there's no retaining. There's a little bumpy retaining clip that you see the little bumps in there. There's another dent that would hold it in place. It's fine for something like this where this doesn't get moved and there's nothing connected to it. This is a temperature and humidity sensor. Like you're gonna just leave it plugged in and it doesn't matter. Can you go to the computer?
Yeah, sorry.
No, it's fine. I just finished talking about USB-A. But for this, because there's going to be this cable attached, it's going to be yanking and moving, and like, maybe the person, pulls on it a little bit by accident or on purpose. I wanted to have a proper USB-A connector. And this looks like Blue Fruit Friend. Like this. So it sticks out a little bit more. It's a little, adds a little bit more expense. But these are fairly through-hole components. So you need to do a through-hole processing step. But what's nice is that they're nice and solid. You see this mechanical through-hole connection. And they really, once it's in, it's like any other USB-A connector. It's a very solid connection. So I sent this off, so we'll get it soon. Very low cost, but like I think a great accessibility to USB adapter. And again, with CircuitPython, it's going to be like so great and easy to be just like different configurations, different scripts, just drag and drop it. And now it's an HID keyboard. Now it's an HID mouse. Now it's something else, MIDI, whatever, for all sorts of accessibility projects. The next one, and because I was talking to Liz about, we did this Elgato Light controller board. Liz did this a few weeks ago. And one of the things that we were chatting about is that there is a protocol from Microsoft called it was like Pixel Array, Light Array, HID. Yeah, lamp array. So they have this new dynamic lighting system, which is like basically NeoPixels. And over HID, you can, whoa, I don't want to see chapter 9. You can do all sorts of controls and light it up. And I think like, you know, they practiced this a little bit with, when we had the Matrix portal, there was like Microsoft had this like controlling code that would let you like draw whatever you wanted on an LED matrix. And so this might be related, but basically they have like all these partners. Everybody who makes like RGB LED toys, you know, keyboards, mice, motherboard, whatever, they're going to add support for it. So it's like, oh, you know, we're probably going to get this working great in Arduino or CircuitPython. So let's make a little Trinky to help with that as well. And it's really basic because it's just, again, a SAMD21. And again, because there's cables coming off the end, it connects to something. I wanted like a solid USB connection. SAMD21 regulator, little mini NeoPixel, just for, because it's a little micro indicator, level shifter. So this is a 74 HCT2 G34, a 2-line level shifter for data and clock, and then 2 100 ohm resistors leading out to a terminal block, which will come pre-soldered. So you can just easily screw in whatever. And so now you can use either 1 DotStar strip or 2 NeoPixel strips. The data and clock could be used for 2 strips if you wanted to. 7021 doesn't have like a lot. I don't think we didn't get DMA working. I mean, you can kind of do it by you know, turning it into an SPI signal, and then you can DMA the SPI. It's like it's possible. It's not great. And these are SPI pins. But I think, again, it's designed to be extremely low cost and simple. It's going to be a couple bucks. You plug it in, you know, and you get NeoPixels out. Okay, and then we're going to wrap this up and go into the great search. We had a request because people were like, well, you know, you're doing these Trinkeys with USB, but a lot of people nowadays have modern Mac laptops, and the Mac laptops have USB Type-C, and we have a little adapter, but it's like, wouldn't it be great if the Trinkey just had USB-C already in? So I got some connectors. Let's go to the overhead real fast. So these are edge, because you want it to be a plug that plugs out. So this is a plug that's actually edge mounted. You see it's actually like mounted in the middle, and it's got a bunch of contacts. The only thing is, I'll say, you know, it's solid, but I don't know. It feels, it's a little wiggly, you know, because it doesn't have a lot of strong mechanical connection. It's got all the connectors, and they're like little pincers, and they pinch onto the PCB, but there isn't like a through-hole component. There's just a lot of SMT pads, which is fine as long as you have a mechanical enclosure that keeps this steady. Another thing is, you need to solder this in. I actually don't even know the process, because you need to have solder on both sides, and then you have to slip this on. So it seems like a very like complicated process to solder this component, because both sides get soldered at the same time, and it has to be hand slotted in. So what I wanted to find to be able to do these Trinkeys is a pick and placeable or easily placeable, not this like edge slotted USB-C plug that's fairly low cost that I can use for my Trinkeys to make my Trinkeys into a USB-C connector. So that's going to be the great search.
Where in the world is that part I need? The great search with DigiKey.
Great search brought to you by DigiKey and Adafruit. Every single week we have Ladyada show you how to find things on digikey.com. Ladyada, take it away.
Okay. I'm designing a bunch of Trinkey boards. Let me show those. Trinkey boards. These Trinkey boards have a USB-A PCB connector that plugs into a port. And they're just very low cost and designed to give you a little bit of capability using a SAMD21 or an RP2040 chip. Here's like a kind of a more advanced Trinkey. Though we had a couple people ask, hey, can you make a version with a USB-C connector? Now, you can't, because USB-C is double-sided and it's also very fine pitch, you can't really make a PCB that slots. I mean, like, you technically could, but it would not last very long. I think the traces would come off pretty quickly. So you can't do this hack where you just have a really thick PCB and these pads. Instead, you do have to have a connector. So what I want though is not a USB-A connector. We have a lot of boards that have USB-A. What I want, USB-C socket. What I want is a USB-C plug. So go to the overhead again. I'll show this real fast. So this is a USB-C plug, right? It matches one of these cables. It's a plug that can solder onto the PCB. But the thing about this is that it's like this straddle mount. I was just talking about this, where all the pins are soldered onto each side. And so this looks like a very time-consuming process because I think you have to apply solder paste to both sides and you have to slot it exactly. It has to fit perfectly in and align. And there's like, they're very fine pitch parts. And there's no through-hole component that goes through the PCB. And so this is like, in my opinion, a little wiggly. You can see this is wiggling. I don't know. It's like a little loose tooth. I think it'll be okay, but I think it'll eventually break off. And so what I want is to find a component on DigiKey that'll let me turn my Trinkey, which I just had in my hand. Here you go. Trinkey, and it's instead of having USB-C socket, like these are, a dime a dozen. We've covered these on the Great Search. I want the opposite with a little bit of through-hole connectivity if possible. Surface mount, but also through-hole, the way the sockets are, so that we can pick and place them. But the components are, the components need hand placement like this straddle mount. Okay, so let's go to the computer. Now we know what we want. So let's go to DigiKey and let's type in USB connector because it's what we want. So we definitely want USB connector assembly. And they have, 4,000, all sorts of things. A lot of micro B, type A, HDMI, whatever. Also like this part that goes onto a cable. So let's first, sorry, there's stuff on my desk. Let's only look for active. And we want it to be a plug. But I'm also going to grab this dash in case there's something that didn't get categorized properly. And I want it to be, not everything is selectable. So now USB type C. There you go. So let's apply. All right, so I'm only at 62. And then I think I'm also going to search for normally stocking because I want to get something that you can actually buy. So there are like a couple of mounting types, but I think the thing is that for something like this, I really want to see the photo and I look at the data sheet because it's like surface mount might include that straddle mount, although they do say, straddle mount here, but maybe do I want board edge surface mount? I don't know. So let's look. And then let's just sort by price to start because who knows. So this one is kind of cool. It looks like a power connector, but it plugs on the tops. This is for like something that would be kind of cool, be a right angle PCB. Ditto, this one is a right angle connector. This one looks like a straddle mount. So let's take a look at this. Let's see if they have the data sheet. They might not, but it's pretty clearly a straddle mount. You can see the little legs, the teens here that they grabs onto the PCB and then yeah, this is bulk. So this is the fact that the packaging is bulk means that it has to be placed by hand. Doesn't come on a pick and place tape and reel. This is also straddle mount. This one is very clearly straddle mount because you could actually even see the 2 layers of pins. I don't want that. This one is like a weird photo, but let's look at what it looks like in person. Also, straddle mount. It's really common. I don't know. I guess if I was like mass manufacturing, maybe I'd go with that. This one, let's look at the 360. Hold on, it's loading. Okay, yeah, this is also a straddle mount. You can see the 2 rows of pins. Boo. Straddle mount. This is also a straddle mount. This one is not actually. This is like the first one that is not a straddle mount. But it's actually going to be, yeah, they don't have the proper full data sheet. Let's see if maybe I can get another data sheet. No. Let's see if we can look at the EDA model. Yeah. So this one is actually possible because it has all the surface mount pins, but they go on the top. And then it has 2 through-hole slots. So this one would actually be okay. This one is a little bit, let's see, yeah, here you go. So you can actually see here's the slot. And then there's the 2 surface mount rows. Only thing is, I don't need 2 rows, and I'm just gonna keep looking. This one, ditto. This one is actually kind of similar to the other one. There's 2 rows of surface mount, and then there's a slot. This one actually would be pretty good. This one's vertical, so that's not gonna work. This is a socket. Don't know why this is in here. Another straddle mount, another straddle mount, another straddle mount. These are really good photos of the straddle mount, though. Vertical, another vertical, straddle mount, and vertical. This is, oh no, there's like a billion. Well, I know that this is, okay. This one's interesting because it's half surface mount, half through hole. It actually probably would be okay to use. This is the footprint. So you see it's actually the full, all the pins, the USB 3 pins. 1 row surface mount, and then the rest are through holes. So this is going to be very mechanically solid. So if I try other stuff and it doesn't work, this for sure is not going anywhere. I mean, like all those through hole connectors plus the slots is going to be super great. This is another 2 slot version, vertical, and then let's look at this. Eventually, I'm going to bump into the one I did pick in the end. Okay, so this is the one. This is the first one that I was like, actually, this is what I want. Because you can kind of see on the footprint, there's only 1 row, because I don't need USB 3. I don't need all the pins. I just want the data, power, and ground, and then like a CC pin. And then it's got 2 slots. It's got a little bit of ground pad to give it a little bit more mechanical connection. But the 2 slots, I think, make it like a good winner. You can see the slots that go through the PCB. And the PCB actually butts up here. You see this is the edge of the PCB. So it jams up against the PCB, and then it has this through hole. So like together, that keeps it from, if you make the PCB cut exactly at the right length, it means it doesn't wedge too much, and it doesn't torque too much. So this is the one I'm actually going to end up using. And I'll just quickly show the USB Type-C plug breakout that I designed with this component. So I'm going to find out if this is going to be a good footprint. That's the thing I have to figure out next. But this is the USB-C like plug. I think this is the correct length. These are all those pads, and then these are the socket, and then the milling layer. Let's see if I can put that front because it's interesting. Let me hide the pads. There you go. You can see this is the milling layer. That's where the slot is going to be cut out, the plated slot. And then there's a little bit of like this ground pad here just for good luck, and we get a little more mechanical connection. and then these pads, and then ideally, you know, this PCB edge again butts up against the connector and gives me that extra mechanical strength. So hopefully this will work. I really want something nice and strong so that people, you know, don't yank, pull, twist. I'll report back if this works. Hopefully my PCBs will show up soon. I'll solder this connector on and I'll let you know. This is my pick for the great search.
That's a great search.
Where in the world is that part I need? The great search with DigiKey.
All right, thanks so much. Please wear your protective glasses if you
Yes.
stare at the sun tomorrow. And we'll see everybody during the week.
Okay, thanks everybody. Have a
Bye-bye.
great solar eclipse week.